So the first one says sine of 38 and cosine of 52. Well, what we're going to do on these 19, 21, and 25, we're going to use the idea that in a right triangle, if we have an angle that we're looking at, whatever size it is, the sine is the opposite over the hypotenuse, and the cosine's adjacent over the hypotenuse. But if this is some degrees here, then over here is its complement. Now remember, two angles that add up to 90 are complementary. So if this one was like 30, this has to be 60. If this is 45, this has to be 45. If this is 38, as in the first problem, this is 52 because they're complementary. So the cosine of 38 would be the adjacent over this. The sine of 52 would be the opposite over the hypotenuse, and so they would be the same. So the sine of 38 opposite over the hypotenuse would be the same as the cosine of 52, which should, now for 52, this would be called the adjacent over the hypotenuse, and so these two are exactly equal. And so the idea here is the sine of 38 is the same as the cosine of 52, or the cosine of 52 is the same as the sine of 38. So the sine of an angle is equal to the cosine of its complement. So, or vice versa. So we could say this is the sine of 38 minus the sine of 38, which is 0. So here we could change the cosine of 10 to the sine of 80, or the sine of 80 to the cosine of 10. In either case, we'd get the same thing over each other, cosine of 10 degrees over the cosine of 10 degrees, which is 1. Again, we're going to do the same thing here. So since this is 20 degrees, this is 20 degrees, I'm going to change. Cosine of 70 is the same as the sine of its complement. Complement of 70 is 20. And so we would have tangent of 20 minus sine of 20 over cosine of 20, but sine of 20 over cosine of 20 is tangent 20. So we'd have tangent 20 minus tangent of 20 degrees, which is 0. Okay, now for this one. It said C is 9 and B is 20 degrees, and it says find other ones. Well, in a right triangle, this would be the complement. A would have to equal 70 degrees. 20 and 70 is 90. And to find these, we would have to say use SOHCAHTOA. So that's the adjacent. 9 is the hypotenuse. And so the cosine of 20 would be the adjacent, A, over the hypotenuse. Or if we multiply both sides by 9, A is 9 cosine of 20. And you can type that into your calculator and get what A is. And B would be opposite, and hypotenuse from B, opposite, adjacent. So we'd say the sine of 20 is the opposite, B, over the hypotenuse 9. So multiply both sides by 9. And so 9 sine of 20. And again, you could type that in calculator and get those values. 64. Now it says, I hope that thing quits adjusting focus here. Okay, so we got an aircraft that's leaving on a runway at an angle of north 40 degrees to the east. So 45 would be right in the middle, so 40 degrees to east would actually be at 50. And it goes 1/2 mile at that angle, where this is 40 here, so this is 50 here. And then it turns 90 degrees to the south and east, so that would be in this direction. And it goes for 1 mile. And it asks what the bearing would be. So it wouldn't necessarily hit here. It might hit below or above this. We're not sure, but it's whatever this is twice as long. So 1, 2, looks like it'll be down here someplace. So what we're looking for, this angle or maybe that angle. Now what do we know? We know that this is 1/2, this is 90, this is 2, so we got side, angle, side. We could use the law of cosines, but at this point we hadn't got those. But we can do leg squared plus leg squared equals a hypotenuse squared. Or we could say, if we want this angle, let's see, what else do we have? We have the opposite leg and the adjacent leg. So the tangent of this big angle would be the opposite over the adjacent, which is 2. So we'd go to our calculator and get the tangent inverse, take the tangent inverse of both sides. Tangent inverse of 2, and this would be, let's see what I'm going to get. My mode is in radians. Let's change it to degrees, and then I'll go back and find that tangent. It says 63 degrees. So this is 63 degrees, the big angle. And if this is 50 above, that means this angle right here is 13.4. 50 from the tangent inverse of 2, 13.4 degrees. So I could say the bearing for where the plane is now is, I could say, east 13.4 degrees to the south. Or I could say south, and then this angle would be 90 minus 13.4. And that is 76.6. 76.6 degrees east. Either one of those would work. This would be this angle, or this would be that angle in there. Okay? And finally, the last one says there's a blimp 500 feet above the ground. There's a stadium over here and a stadium here, and when it looks down from horizontal to this one, it makes an angle of depression of 32 degrees. When it looks over to this one, it makes an angle of depression of 23, and they want to know how far these are apart. Well, we have two right triangles here, since it was at 500 feet. We can find this one. See, this would be 500 feet. 32 is this angle, and we can subtract it from 90 and get this one, but I also know that if that is parallel to the ground, this has to be 32 degrees. So I will use that and say that's the opposite, and I need the adjacent. So that would be tangent, so I'll have the tangent of 32 degrees is 500 over A, that piece I want to know. And I can solve this for A and get that length. And similarly over here, if this is 23 degrees and alternating interior angles from geometry, this has to be 23 degrees, or this is 90 minus 23, but I'll do it that way. And so then I'll have the tangent of 23 degrees is opposite, 500 feet, over this one that I want to find, B. Now solve for B, I can multiply both sides by B and divide by the tangent of 23, and I get B to be 500 divided by tangent of 23 degrees. And so that's, put it over here so you can see it, 1,178 feet. And A would be basically the same thing, but with 32 degrees, and that's 800 feet. So the two stadiums are apart by 1,978